We are putting more CO2 into the atmosphere. CO2 is a greenhouse gas which traps the infrared radiation and heats up the planet.
Buildings are, depending on which stats you look at, about 40% of the problem. Some of that's due to the energy they use, some of that's due to the carbon intensity of everything that goes into a building. So if we really want to solve that, we've got to solve it on the energy side, and we've got to solve it on the building embodied carbon side. The energy side you typically solve with renewables. The building side, you can solve it with mass timber buildings, which essentially sequester that carbon in the building for years and years and years.
We have to wean ourselves off of fossil fuels and stop mining stuff out of the earth to build buildings. We need to switch to an economy where we can build structures out of materials that we can sustainably grow on the surface of the earth. And mass timber is a huge step in that direction.
Forests in the U.S. as a whole are acting as a huge net sink, on the order of about 700 million metric tons of CO2 equivalent a year, which it offsets about 10 to 12% of U.S. emissions.
The promise of mass timber construction is the ability to expand this sink, to store more carbon in traditional and as an add-on to traditional building practices, but also the ability to move into a whole new class of construction with multi-story buildings. And that one is particularly important because then we can substitute for concrete, steel, aluminum, and plastics, which are a real detriment from a carbon perspective.
Mass timber, the wood product, 50% of it is carbon. As that tree grows and sequesters nutrients out of the soil, sequesters water out of the soil, sequesters carbon dioxide of the atmosphere to form those cells in the wood, that's carbon. So if we can take these trees that sequester carbon, put them into a building that has a 75-year to 250-year lifespan, that helps reduce our pollution on the environment.
Wood is grown, it's renewable. It's something that you can return. So when you excavate materials to create concrete structures or steel structures, those never go back into the earth and they don't regrow. Mass timber offers probably one of the best ways right now that we can innovate and integrate this idea of reducing carbon into our work.
So how do you assess the carbon impact of the materials that are used to make a building, otherwise known as embodied carbon? So that should be done at the whole building level and look at the entire life cycle, from extraction through manufacturing, through transportation, and finally through end of life. And when you compare like for like at the building level, generally speaking, wood buildings have a lower embodied carbon than alternative materials.
Because climate change is this really sort of current problem, we have a 20, 30-year horizon where we really need to start to turn things around. And when you build a new building, you have all of this carbon that goes into those materials. And so there's a cost that happens that you have to take day one, and then there's the after cost. And so that's where that embodied carbon piece becomes really, really important.
On the research side, relative to this question of sustainability and mass timber and the impact that this may have, I think it's really going to center around climate change and wildfire and how much carbon can be stored in living material out on the hillsides versus how can we collect that material proactively in advance of wildfire or post-fire, how that carbon could be collected and placed into buildings rather than just decomposing on the hillsides.
Now we're talking about the idea rather than just reducing carbon and making it kind of like net zero carbon, but what about making things net positive carbon and then even regenerative? And so it's an exciting moment. And those conversations are happening with clients. It's not just us. Now the clients are curious and asking, and we're saying, well, if you wanted to, you could make your building, net zero carbon or net positive carbon by doing these things. Mass timber is an important and critical part of that. You cannot do that as easily without integrating in an all-wood structural system.
I love trees. My 3 kids are named after trees, and I am a firm believer that trees can kind of solve the world's problems.